Base your answers to questions 51 and 52 on the information below and on your knowledge of chemistry. Compounds that contain the element boron, such as boric acid and sodium borate, produce a green flame when a sample of one of these compounds is placed in a laboratory burner flame. If this flame is viewed through a spectroscope, a bright line spectrum is seen. State how the bright line spectra of known elements can be used to identify an unknown element whose bright line spectrum was viewed through a spectroscope. Each element has its own spectral wavelength. By matching the wavelength of the unknown element to that of a known element, you can see what element the unknown element might be. State in terms of electrons and shells why the electron configuration 221 is an excited state electron configuration of a boron atom. The original electron configuration of a boron atom on the reference table is 2,3. Boron with an electron configuration of 2,2,1 is in the excited state because an electron from the second shell is moved to the third shell. Base your answers to question 53 through 55 on the information below and on your knowledge of chemistry. Silicon is an element in group 14 on the periodic table. The atomic mass and natural abundance for the three naturally occurring isotopes of silicon are shown in the table below. Draw a Lewis electron dot diagram for an atom of silicon in the ground state. In order to draw an electron dot diagram for silicon, you have to draw the name of the element, Si, and draw the amount of electrons in the valence shell around the symbol for the element. Silicon has 4 electrons in its outer shell, so you should draw 4 circles or electrons around the symbol Si. Compare the energy of an electron in the first shell of a silicon atom to the energy of an electron in the third shell of the same atom. Electrons have more energy as they move away from the nucleus. Therefore, an electron in the first shell of a silicon atom will have less energy than an electron in the third shell of the silicon atom. Show a numerical setup for calculating the atomic mass of the element silicon. To calculate the atomic mass of the element, we must multiply the isotope's mass by the isotope's natural abundance. In the equation, the natural abundance must be in percent form. So for example, 52% should be 0.52 in the equation. Or if you choose to keep it as 52, the entire equation should be divided by 100. For silicon, we can do 27.98 U times 0.9222 plus 28.98 U times 0.0469 plus 29.97 U times 0.0309. Since it asks for the setup, you do not have to calculate the answer. The unbalanced equation below shows a reaction between nitrogen monoxide gas and oxygen gas to produce nitrogen dioxide gas. State in terms of reactants and products why this reaction is a synthesis reaction. A synthesis reaction is when simple elements combine to form a more complex product. As we can see in the reaction, NO and O2 form NO2. The two elements form one product. Balance the equation in your answer booklet for the reaction using the smallest whole number coefficients. To balance the equation, there must be an equal amount of all the elements on both sides of the equation. You can rewrite the equation and leave a space for a coefficient in front of the compounds or elements. On the reactant side, there is one nitrogen element and 3 oxygen elements. On the product side of the equation, there is one nitrogen element and 2 oxygen elements. Now, I can see that if I put a 2 in front of nitrogen oxide and a 2 in front of the nitrogen dioxide, there will be 2 nitrogen elements and 4 oxygen elements on each side of the equation. Determine the percent composition by mass of oxygen in the product NO2. Gram formula mass equals 46 grams per mole. On the back page of the reference table is the equation percent composition by mass equals mass of part divided by the mass of whole times 100. We are trying to find the percent composition mass of oxygen and NO2. You can set up the equation as 2 times 16U divided by 46 times 100. The least number of significant fakes is 1, so the answer, 69.57, can be rounded to 70. I think the Regents would probably also accept 69.57, but it's nice to remember your sig figs. Base your answers to questions 59 and 60 on the information below and on your knowledge of chemistry. The ionic radii of 4 group 17 elements are given in the table below. Identify the noble gas that has atoms in the ground state with the same electron configuration as a bromine ion in the ground state. If you look at the periodic table of elements, bromine has an electron configuration of 2, 8, 18, 7, but the bromine ion has an electron configuration of 2, 8, 18, 8. The noble gas with the electron configuration of 2, 8, 18, 8 is Kr krypton. State in terms of electrons why the ionic radius of a group 17 element is larger than the atomic radius for the same element. When an atom of bromine becomes an ion, an extra electron is added to its electron configuration to complete its outer shell. Adding this extra electron makes the ionic radius larger than the atomic radius of bromine. The group 17 atoms must gain an electron to become an ion. The diagram below represents 2 sealed, rigid containers and the conditions of pressure, volume, and temperature for each container. Container A is filled with N2, and container B is filled with O2. Explain, in terms of the strength of intermolecular forces, why the gas in container B at standard pressure has a higher boiling point than the gas in container A at standard pressure. The higher the boiling point, the stronger the intermolecular forces. So you can write, the gas in container B has a higher boiling point because it has stronger intermolecular forces. In the space in your answer booklet, show a numerical setup for calculating the pressure of the gas in container B is equal to standard temperature. To write the setup for this question, you can turn to the back page of the reference table and see the equation P1 V1 over T1 is equal to P2 V2 over T2. It says when the gas in container B is equal to STP, and STP is 273 K. The volume of both containers is 750 ml, so you don't have to include volume in your setup, but you can if you want to. The pressure of container A is 101.3 kPa, and the temperature is 298 K. So the setup can be 101.3 kPa over 298 K is equal to P2 over 273 K. The table below shows the formulas of 3 organic compounds and a chemical name for each one of the compounds. Identify the element in these 3 compounds that allows them to be classified as organic compounds. You have to remember that the presence of carbon in a compound allows it to be classified as an organic compound. Identify the class of organic compound to which compound 1 belongs. To answer this question, you can turn to Table R. It's helpful to look at the column functional group and then look at compound 1. Compound 1 has an oxygen with 2 electron pairs bonding it to a carbon, and the carbon atom is bonded to another carbon atom and an oxygen atom. Looking at Table R, this means that compound 1 is an ester, because an ester has a carbon atom bonded with an oxygen atom through 2 electron pairs, and the carbon atom is bonded to another oxygen atom on one side. Write a chemical name for compound 2. The molecular formula of compound 2 is CH3CH2 COCOH. Looking again at Table R, this is the exact molecular formula that they provide as an example of an organic acid. The answer to this question is propanoic acid. The periodic table of elements has changed over the past 150 years. During this time, many elements have been added as they were discovered. The elements 113, 115, 117, and 118 in period 7 were named in 2016. Their official names have been approved by the International Union of Pure and Applied Chemistry. The table below lists the names, symbols, and atomic numbers for these 4 elements. Identify the element in this table that is located on the periodic table of elements in the group classified as noble gases. Looking at the periodic table of elements, I look to find the elements with the atomic numbers 113, 115, 117, and 118. The element with the atomic number 118 in group 18, UUO. Explain in terms of valence electrons why the elements nihonium and tennessine would be expected to differ in their chemical properties. NH is nihonium and TS is tennessine, which belongs to group 13 and 17 respectively. Since they belong to different groups, they will have a different amount of valence electrons, which means that they will have different chemical properties. Describe the general trend in first ionization energy values as the 5 elements above moscovium in group 15 on the periodic table of elements are considered in order of increasing atomic number. This is one of the trends on the periodic table. The ionization of the elements in group 15 will decrease as the atomic number increases. This is because the forces of attraction between the electrons and the nucleus will decrease as the amount of electron shells increases and the electrons move farther away from the nucleus. State in terms of protons why tennessine is listed before oganesson in period 7 on the periodic table of elements. The atomic number represents the amount of protons in an element. Atoms of tennessine have 117 protons, and atoms of oganesson have 118 protons. Hydrogen gas is needed for many industrial chemical reactions. An equilibrium system that includes the use of a catalyst produces hydrogen from methane, and steam is shown in equation 1 below. Another equilibrium system produces hydrogen gas as represented by equation 2 below. Compare the rate of the forward reaction to the rate of the reverse reaction for the equilibrium system at equilibrium represented by equation 1. The rate of the forward reaction will always be equal to the rate of the reverse reaction. State how the equilibrium shifts when the temperature of the equilibrium system at equilibrium represented by equation 1 is increased. The equilibrium will shift to the right as the temperature increases because on the right side of the equation there is 210 kilojoules, which represents heat. State, in terms of activation energy, why the catalyst increases the rate of the forward reaction represented by equation 1. The catalyst will lower the activation energy because the catalyst will make more collisions more likely to occur. On the labeled axes in your answer booklet, draw a potential energy diagram for the forward reaction represented in equation 2. The potential energy diagram will either show an endothermic reaction or an exothermic reaction. An endothermic reaction absorbs heat, while an exothermic reaction releases heat. In equation 2, heat is released as a product, so it is an exothermic reaction. An exothermic reaction shows a line and then a curve, and the curve continues down past the original line into another straight line. The diagram and balanced ionic equation below represent an operating voltaic cell. State the form of energy that is converted to electrical energy during the operation of this voltaic cell. Chemical energy will be converted into electrical energy because the chemical reaction generates the energy. Identify one metal from Table J that is more easily oxidized than copper and less easily oxidized than iron. A metal that is more easily oxidized than copper will be above copper on Table J, and a metal that is less easily oxidized than iron will be below iron on Table J. We're looking for the elements that are between iron and copper. You can write CO, Ni, Sn, or Pb. Do not include H2. State the purpose of the cell bridge in completing the circuit in this cell. You just have to remember that the cell bridge keeps the solutions electrically neutral and allows for the free flow of ions from one cell to another. Write a balanced equation for the half reaction that occurs in the copper half cell. In the half reactions, copper is written as Cu plus 2 and then as Cu. Going from Cu plus 2 to Cu means that 2 electrons were added to make it an atom once again. In a laboratory investigation, 0.01 moles of NaOH solution with a pH value of 12 is used to determine the molarity of an HCl aqueous solution. A 10 milliliter sample of HCl is exactly neutralized by 20 milliliters of 0.01 m NaOH. During this laboratory activity, appropriate safety equipment is used and safety procedures are followed. State the color of the indicator litmus in a sample of the original NaOH solution. If you go to Table M, it says that for the indicator litmus, from the pH range 4.5 to 8.3, the color is red to blue. The pH of NaOH is 12. 12 is greater than 8.3, so the color of litmus will be blue. Determine the pH value of a solution that has a hydronium ion concentration 100 times greater than the original NaOH aqueous solution. The pH of NaOH is 12. Increasing the concentration by 100 times, or 10 to the power of 2, will make the pH 10. This can be done by taking 12 minus 2. Because 100 is 10 to the second power, you have to pay attention to the exponent. Identify the positive ion in the original HCl aqueous solution. The hydrogen ion will be the positive ion in the solution. Determine the molarity of the HCl aqueous solution using the titration data. Turn to the back of the reference table and look at the equation molarity equals moles of solute divided by liters of solution. The equation can be arranged 0.02 times 0.01 to represent the 20 milliliters of 0.01 m of NaOH because 20 milliliters is equal to 0.02 liters. The amount should be divided by 0.01 because 10 milliliters is equal to 0.01 liters. This makes the answer 0.02 m. Spacecraft sometimes use a nuclear power source that produces electricity from the heat released by the decay of radioisotopes. Two radioisotopes that have been used in these nuclear power sources are plutonium-238 and americium-241. Both the Pu-238 and Am-241 emit alpha radiation and gamma radiation. The half-life of Am-241 is 432.7 years. Other sources of electrical energy for some spacecraft have been solar panels and batteries. Determine the fraction of Am-241 remaining from an original sample after 865.4 years. The half-life of Am-241 is 432.7 years. After 865.4 years, there will be one-fourth of the sample left, because after 432.7 years, half of the sample will be left, and after another 432.7 years, or a total of 865.4 years, one-fourth of the sample will be left. Compare the penetrating power of the alpha particles to the penetrating power of the gamma radiation. Gamma rays have the greatest penetrating power because they have no charge. Therefore, they will not interact as strongly with particles of matter as strongly as particles with charge. Complete the nuclear equation for the alpha decay of Pu-238 by writing a notation for the missing nuclide. With an alpha decay of an atom, the alpha particle must be released on the product side of the equation. Pu has an atomic number of 94 on the periodic table. An alpha particle has a mass of 4 and an atomic number 2. The missing particle plus the alpha particle must have a combined mass of 238 and a combined atomic number of 94. 238 minus 4 equals 234, and 94 minus 2 equals 92. The missing particle must have a mass of 234 and an atomic number 92. The element is uranium. Compare the energy released by the radioactive decay of 1 kilogram of Pu-238 in this nuclear power source to the energy released by 1 kilogram of chemical reactants in a battery. The energy released by 1 kilogram of Pu-238 will be greater because it's nuclear energy, which is very powerful.